Good evening, everyone. Today, we're diving into the fascinating world of astronomy, focusing on the celestial body at the heart of our solar system, the Sun. Before we explore the scientific aspects, let's delve into the cultural significance. In Greek mythology, the Sun is personified as Helios. In Hinduism, it's revered as Surya, and in Egyptian mythology, it takes the form of Ra. Sun is the solar system's heart. Now, let's talk about the Sun as the heartbeat of our solar system. It's the source of energy for all life on Earth, providing the light and warmth necessary for our existence. Distance from the Milky Way, did you know? The Sun is not stationary, it's part of the Milky Way galaxy. The estimated distance from the Sun to the center of the Milky Way is around 27,000 light-years. Speed of solar orbit. As the Sun gracefully orbits the Milky Way's center, it travels at an impressive speed of approximately 230 kilometers per second. Period of revolution. The Sun completes one full revolution around the Milky Way's center in a grand cosmic dance, taking approximately 25 crore years. Sun's rotation. Let's focus on the Sun's internal motion. The central part, near the equator, completes a rotation in just 25 days, while the polar part takes a leisurely 35 days. Structure of Sun. In this slide we see the image of structure of Sun which containing part core, connective layer, photosphere, chromosphere, corona, sunspot. Structure of the Sun, core. Now, let's journey into the heart of the Sun. The core, the innermost layer, is where nuclear fusion occurs. Temperatures soar to a staggering 1.5 crore degrees Celsius. Hydrogen nuclei transform into the helium nuclei and large amount of nuclear energy. Structure of the Sun, connective layer. Above the core lies the connective layer, where energy generated in the core is transported by hot plasma through large convection currents. Photosphere. The bright white disk we see in the sky is the photosphere, the outer layer of the Sun where light is radiated. Let's take a visual journey through the photosphere. Solar atmosphere layers. The Sun's atmosphere is divided into 3 layers: the chromosphere, transitional zone, and corona. These layers play key roles during events like solar eclipses. Let's explore the dynamic layers of the Sun's atmosphere, each with its unique characteristics. Chromosphere. Starting with the chromosphere, it's the upper layer of the photosphere. During a full solar eclipse, the chromosphere unveils itself with a bright pink flash, adding a mesmerizing touch to the celestial spectacle. Transitional zone. Moving outward, we encounter the transitional zone. This region is where the temperature undergoes a significant rise, transitioning from the 5,500 degrees Celsius temperatures in the photosphere and chromosphere to levels surpassing 1 million degrees in the corona. Corona. Finally, we reach the outermost layer, the corona. This ethereal layer is visible during a solar eclipse, appearing as a delicate halo around the obscured Sun. Solar eclipse occurrence. Speaking of solar eclipses, these celestial events provide a unique opportunity to witness the chromosphere and corona. As the Moon aligns perfectly with the Sun, it temporarily conceals the bright disk, unveiling the outer layers in a cosmic dance. Scattering of light. One fascinating aspect is the scattering of light in the solar atmosphere. The interplay of particles in these layers contributes to the beautiful phenomena observed during solar eclipses, enhancing our understanding of the Sun's outer realms. In summary, the Sun's atmosphere is a layered masterpiece, each layer revealing its own secrets during specific astronomical events. From the chromosphere's vibrant pink flash to the corona's gentle glow during a solar eclipse, the solar atmosphere never ceases to amaze. Now, let's explore the intriguing phenomena on the Sun's surface known as sunspots. Sunspots are dark, cooler areas on the Sun's surface, created by the intense magnetic activity beneath. These phenomena are essentially temporary hollow spaces. Interestingly, the temperature within a sunspot is about 1,500 degrees Celsius less than the surrounding areas of the Sun. Sunspots have a brief appearance, typically visible for 1 to 2 days to 2 to 3 months. They come and go, creating a dynamic landscape on the solar surface. When sunspots appear, they can have consequences here on Earth. One notable effect is the production of magnetic storms. These magnetic storms can interfere with our technological infrastructure, causing disturbances in electrical appliances such as radios, TVs, and electric motors. During such periods, these devices might become noisy or exhibit unusual behavior. Beyond technological disruptions, sunspots can also impact navigation tools. Compasses, boat pullers, and steamer pullers may experience direction confusion during increased sunspot activity. In essence, sunspots, though small and short-lived, play a significant role in the solar-terrestrial relationship, influencing both technology and navigation. Solar cycle. Now, let's dive into the captivating phenomenon known as the solar cycle, a rhythmic dance of solar activity that occurs over an 11-year period. Solar maximum, peak of activity. At the peak of the solar cycle, we encounter what's known as the solar maximum. This is the sun at its most dynamic and vibrant state. During this period, more than 100 sunspots can be observed on the sun's surface. These dark, cooler areas indicate intense magnetic activity. Solar minimum, tranquil phase. Conversely, the solar minimum marks a tranquil phase in the solar cycle. At this time, sunspots become elusive, and the sun appears relatively calm. In fact, during some solar minima, there may be no sunspots visible at all. It's a period of relative solar quietude. The solar cycle is a fascinating journey of approximately 11 years, characterized by contrasting phases, the lively solar maximum and the serene solar minimum. Additionally, the 22-year solar magnetic activity cycle introduces us to the captivating phenomenon of magnetic polarity reversals, providing a deeper understanding of the sun's magnetic dynamics. Important facts about the Sun. Let's conclude with some quick facts about the Sun. Time of revolution, 25 crore years, rotating at an average speed of 250 km per second. Time of rotation, 25 days at the central part, 35 days at the polar part. Diameter, approximately 14 log km. Relative mass, 3 logs times that of Earth. Density, 1.41 grams per cubic centimeter. Core temperature, 1.5 crore degrees Celsius. Chemical composition, hydrogen, 71%, helium, 26.5%, other elements, 2.5%. Lifetime, approximately 10 billion years. Age, about 5 billion years. Thank you for joining our cosmic exploration today. If there are any questions or thoughts, feel free to share. Have a stellar day.